testing can find runtime errors. There's only one thing that is really critical that you must have. You must be lucky. Now, that's your lucky day. That's March 17th, and March 17th is St. Patrick's Day. Yeah, the luck of the Irish. Take a very simple example where you have one function that has a char, an unsigned char. So it's between 0 and 255, and there's only a few values in that parameter that can be passed inside the function that is going to trigger, say, an overflow or an out-of-bound array. Problem is that if you're not testing these values, you're not going to see it. Sure, sometimes these values are going to be on the boundaries of that parameter. Maybe 0 needs to be tested, maybe 255 needs to be tested, but sometimes they are going to be right smack in the middle of that range. And no, you won't be able to test all of the values, right? With real software and lots of data, yeah, exhaustive testing is not possible. Even if you happen to hit the right values and the runtime error happens, sometimes it's silent. Maybe it's going to be symptomless. So say, for example, that you're writing to memory and it's outside the bounds of your memory array. You're not going to see it until it gets read. So testing is very good at verifying requirements. That's a given. It has its place in software verification, but to find runtime errors, it requires a bit of luck. And unfortunately, you can rely on luck in order to guarantee total robustness and total reliability. This is where exhaustive static analysis comes in. It uses the power of formal methods to know exactly what kind of range of values can be seen at different points in your program, and thus derive whether certain operations may actually return a runtime error. It will pinpoint in the code directly where these faults can happen mathematically during execution. And if your static analysis tool is based on formal methods, it's going to be exhaustive. Yeah, that means that it's never going to ignore any runtime error. And yet, not bury your head under tons of false positives.